All right, hi guys. I'm just going to walk through each of the questions. Feel free to watch as many or as few as you need. So the first one is talking about Red Hook High School's got 480 freshmen. Of the freshmen, 333 take algebra, 306 take bio, 188 takes both. So when it's saying which of the following represents the number of freshmen who take at least, all right, one of the two classes, essentially that's the same as saying what's the probability that they take algebra or they take bio. So if we want to use the new rule, the rule is if we say one or the other, is we are adding up everybody who took algebra to everybody who took bio and then just subtracting the number that take both, or those that are in the overlap. So in this case, we got 333 took algebra, 306 bio, and then minus 108 or 188 who took both. Because you don't want to double count those people. That's basically the idea behind it. So if we go, brighten that up a little, 333 plus 306, and then minus 188, we get 451. Keep in mind, there's only 480 to begin with, so like this would make 0 sense right there. All right, number 2. You have a standard 6-sided die. Which is the following is the probability that the outcome was less than 3 or it was even. All right. There's a couple ways you could do this, but if we're following the rule, the probability that it's less than 3 or it's even. All right. So less than 3. That means you're rolling a 1 or a 2. Even. That means you're rolling a 2, 4, or a 6. So if you play the game of the rule, less than 3, there's 2 cases out of 6, plus even, there's 3 cases out of 6, minus, well, a 2 is in the overlap. So there's 1 case of getting that 2 where it's both. So in this case, you'd come out with 4 out of 6 and get 2/3. Now, do I have to use the rule? No. You guys could have just said it was either a 1, 2, a 4, or 6. There's the 4 out of 6 right there. But it's just showing that the rule works. All right, next one. Survey was done of students in a high school to see if there's a connection between the student's hair color and their eye color. So if a student's picked at random, find the probability of each. So this is empirical probability because it's based on this survey that they did. All right. So the student had black hair. So if we're looking at the chart, hair color is here. So black hair, it's the total at the bottom there. So that is just 0.45. Right. The probability that they have blue eyes, so find blue eyes, go all the way to the total, that is 0.40. The student had brown eyes and black hair. So if it's and, we're going in the overlap. All right, so this and that. So brown eyes and black hair. So this right here, that's going to be the 0.25. All right, if the student has blue eyes or blonde hair, all right, using the rule, that's all the people that had blue eyes plus all the blondies, and then minus those that have both. So if I look at the chart, blue eyes, that's all 0.40 of them. Blonde hair, that's all 0.35. And then the people that are blue eyes and blonde hair, those 0.20, they've been counted twice. So let's remove that from it. So that would give you 0.75 minus 0.20. That'll give you 0.55. Right. The next one, the student had black hair or blue eyes. So same game. Black hair plus blue eyes minus anybody that's got both of those traits. So the total number of black hair, that's 0.45. Total with blue eyes, that's 0.4. And then if we look at where black and blue overlap, there's 0.15 that have been counted twice. that would give me 0.85 minus 0.15, so 0.70. That's going to be the probability that they've got one or the other. All right, last one. Are all of these examples theoretical or empirical? I already talked about that. These are empirical probabilities because it's based on data or like a survey, however you want to think of it here. All right, not in theory what would happen. It's actually based on collecting data. Okay, on the back. Oops, over here. For number 4, FHS surveys families of its students and determines the following. If a family is chosen at random, the probability they own a dog, 0.64, probability they own a cat, 0.32, probability they own a dog and a cat, 0.11. All right, it does say sketch a Venn diagram. You know how I feel about this. So I'm going to do a two-way table. If you would like to do a Venn diagram, I will put that here as well. So for a Venn diagram, this would be, you got a dog, you got a cat, you got both, so that's the 0.11. And then if you got nothing, that's going to go down here. All right, I'm going to do the two-way here. So a dog versus no dog, and the total. And then a cat versus no cat, and the total. Okay, so here, they own both. That's the 0.11 between cat and dog. All right, if you own a dog, go all the way to the bottom, 0.64. You own a cat, go all the way over, 0.32. It's always going to be 1.0 when we're talking probability. So if this is 0.64, you're going 1 minus 0.64 to get the 0.36 here. You can go 1 minus 0.32 to get the 0.68 here, and then keep it backfilling. So take 0.64 and subtract 0.11. That would leave us with 0.53. If I work my way across, 0.32 minus 0.11, here's 0.21. And then finally, I can work my way across again, 0.68 minus 0.53. That's 0.15, all right? If I had done the same thing over here, I would have had to stop to subtract 0.11 from 0.64 to get this 0.53. That would have gone over here in the dog but no cat, so over here, so 0.53. Under cat but no dog, you have to subtract the 0.11, 0.32. That's this. And then those that own nothing goes over here with 1 being the total. So when it says determine the following probabilities, all right, remember U means union. Oops, hold on 1 second. All right, so when it's the union, we list everybody. All right, so probability of a dog or a cat. That means I want all of the dog owners plus all of the cat owners. Just take out anybody that we've counted twice, because union, that's the same as or. All right, so all of my dog people, that's 0.64. All of my cat people, that's 0.32. And those that own both, that's 0.11. There we go. So 0.64 plus 0.32 minus 0.11, 0.85. Now, if you wanted to, could you go in the chart and just add up, like, you know, the individual values themselves? Sure, but the rule works, right? For this one, this is an and. So I'm looking for the overlap. Where do these guys like share? So dog complement means no dogs, and cat complement means no cats. So no dogs, no cats. It's just that 0.15. That's it. Mm-hmm. This one, sometimes this one messes with people a little bit, but if we use the rule, this is saying a dog or, right, no cat. So when I see union, that's the same as saying or, right? Because you're going to list everybody that fits into this category. So all your dog owners, all of your non-cat owners, minus anybody that fits in both of those categories. All right, so all my dog people, that's 0.64. Anybody that doesn't own a cat, so no cat, that's 0.68. And then the people that fit into both of those categories, so the dog category and no cat, this is the overlap. This is who fits into both. So minus 0.53. So if we go 0.64, oops, 0.64 plus 0.68 minus 0.53, that's going to leave us with 0.79. I know it's a little tough to see on my calculator, but you can see it on my paper there. Next up, of the works of an art gallery, saying 59% are paintings, 83% are for sale. So those are our two categories. We got paintings, we've got for sale. When a work of art is selected at random, let the event be, that is a painting, be A, for sale is B. Okay, so it's a painting, it's for sale. So what are the values of those probabilities? So probability of A, so since A is the painting, that would be 0.59, right? Probability of B, that is it being on sale, that is 0.83. Right, suppose you're told that the probability of A and B is 0.51. Find A or B. So here's where we're specifically applying that rule. So the probability of A or B is A plus B minus, oops, sorry, I'm getting ahead of myself there, A and B. So we got 0.59 plus 0.83 minus that 0.51. All right, add it all up. So 0.51 plus 0.83 minus 0.51. Oops. 0.59 plus 0.83 minus 0.51. There we go. So 91. So the probability that it's either a painting or it's on sale is really, really high. So just about everything in there. All right. Probability a car owner has a convertible is 0.3, a sedan is 0.2, and both a convertible that's a sedan is 0.1. What is the probability that the car owner has a convertible or a sedan? All right, same thing. So the probability of a convertible or a sedan, keep following that rule. Probability of the one plus probability of the other minus probability that it's both of those things. So 0.3 plus 0.2 minus 0.1. So that would be 0.5 minus 0.1, so 0.4. All right, last one. We have a bag of 12 jelly beans. So 4 beans are red, 2 beans are green, 5 are yellow, 1 is purple. All right, so let's see. 4 red, 2 that are green, 5 are yellow, 1 is purple. All right, what is the probability that a bean is red or green? The rule still works. All right. Probability of red plus probability of green minus the probability that it's both. Well, it sounds kind of silly, but there's 4 red ones out of, let's see, 4 plus 2 is 6. Plus 5, we got 11. We got 12 total. Oh, geez. Should have looked back up there. All right. So the probability they're red, probability that they're green, minus the probability they're both. Well, there aren't any that are both. So minus 0. It's just 6 out of 12 or 1/2. So when you have a case like that, you don't really need the rule. It's just count them on up, see what you end up with. All right. But if you have any scenarios where they're going to overlap, you have to consider and make sure that you don't double count those people or items or things. All right. I'm just going to quick double check against my answer key and make sure I didn't goof anything up before I end the video. So number 3 should have been 3. This guy should have been 1, and it was. I just didn't circle it. 0.45402557 in empirical. All right. We did our charts. Part B is 0.85, 0.15, 0.79, 59, 83, 91. Cool. And then this is a case where since they're given as percents, it's okay if you listed them as percents. So if you said 59%, 83%, and 91%, it would be okay. All right. 6 should have been 0.4. 7 was a half. All right, we're golden. Have a fabulous day.